Hello, and welcome to the IoT Chat, where we explore the latest development in the Internet of Things. I'm your host, Christina Cardoza, Associate Editorial Director of Insight.Tech. And today, we're talking about machine learning as part of your data strategy with Eric Bovey from MindsDB. But before we jump into the conversation, let's get to know our guest. Eric, welcome to the show.
Thank you. Yeah, it's great to be here.
What can you tell us about MindsDB and your role there?
So MindsDB is a machine learning service, and we'll kind of get into the details. But the goal of MindsDB is to democratize machine learning, make it easier and simpler and more efficient for anybody to deploy sophisticated machine learning models and apply them to their business. I'm the vice president of business development, which is kind of a generic title with a really broad role. I'm responsible for our sales, but that's kind of a combo of project management, some product management, kind of do everything with our customers. And then a really important aspect that I handle are our partnerships. So one of the unique things about MindsDB is that we enable machine learning directly on data in the database. So we connect to a database and allow people to run machine learning, especially on their business data, do things like forecasting, anomaly detection. So I work with a lot of database providers, MySQL, Cassandra, MariaDB, Mongo, everybody. And that's one of the key ways that we take our product to market, working with data stores and streaming brokers, data lakes, databases to offer machine learning functionality to their customers. So I'm in charge of that. And also work with Intel. Intel's provided a lot of support. They're very close with MariaDB, who's one of our big partners. And Intel also provides OpenVINO, which is a framework which helps accelerate the performance of our machine learning models. So I'm in charge of that as well.
Great. I love how you mentioned you're working to democratize machine learning for all. I don't think it's any surprise to businesses out there that machine learning has become a crucial component of a data management strategy, especially, when all the influx of data is coming from all of these IoT devices. It's difficult to sift through all of that by yourself. But a challenge is that there's not a lot of machine learning skills to go around for everybody. So I'm wondering, let's start off the conversation if you can talk about what the state of machine learning adoption looks like today.
Yeah, I mean, you summed up a couple of the problems really well. The amount and the complexity of data is growing really quickly. It's kind of outpacing, human analytics and even like algorithmic type analytics, traditional methods. And also machine learning is hard. Finding the right people for the job is kind of difficult. These resources are scarce. But in terms of the state of the market, there are a couple of interesting angles. First, the state of the technology itself and like core machine learning models is amazing. There's the progress made over the last 5 to 10 years is really astonishing. And cutting edge machine learning models can just solve crazy hard real world problems. If you look at things like what OpenAI has done, or with their large like GPT-3, like large language models, which can produce human-like text, or even consumer applications. You probably heard of MidJourney, which you can access via Discord, which based on a few keywords can produce really sophisticated, remarkable art. There was a competition, I think it was in Canada recently, that a MidJourney produced piece won, much to the annoyance of actual artists. So the technology itself can do astonishing things. From an implementation standpoint, though, I think the market has yet to benefit broadly from this. Even autonomous driving is still more or less in the pilot phase. And the capabilities of machine learning are amazing in dealing with big problem spaces, dynamic real world problems. But adapting these to consumer tech is a process. And there are all kinds of issues that we're kind of tackling along the way. One is like trust. Not just can this thing drive me safely, but then also like, how do I trust that this model is accurate? Can I put the fate of my business on this, forecasting model? How does it make decisions? So those are, I think those are important aspects to getting people to implement it more broadly. And then I think one of the things that's really apparent in the market, and as I'm dealing with customers, are some of the hurdles to implementation. So cutting edge machine learning resources are rare, like we said, but then also a lot of the simpler stuff like machine learning operations turns out to be more of a challenge, I think, than people anticipated. So the data collection, the data transformation, building all the infrastructure to do this, like ETLing data, extracting, transforming it, loading it from your database into a machine learning application, and then maintaining all this piping and all of these contingencies, model serving is another one. Like your web server is not going to cut it when you're talking about large machine learning models for all kinds of technical reasons. And these are all being solved, piecemeal as we speak, but the market for that is in an early stage. And those are dependencies that are really important for broad adoption of machine learning. But I would say there are a few sectors where commercial rollout's moving pretty fast, and I think they're good bellwethers for where the market is headed. Financial services is a good example, and it has been for a few years. Big banks, investment houses, hedge funds, they've got the budgets and the traditional approach to hiring around a good quant strategy. They're moving ahead pretty quickly and often with well-funded internal programs that give them a really big edge. But they've got the money to deploy this, and it's this kind of narrow business advantage for things like forecasting, algorithmic trading are tremendously important to their margins. So I've seen a lot of progress there. But a lot of it is also, throwing money at the problem and kind of solving internally these ML ops questions, not necessarily applicable to the broader market. The next are, I would say, industrial use cases. You had mentioned IoT. That's kind of where I see a lot of progress as well, especially in things like manufacturing. For example, taking tons of high velocity sensor data and doing things like predictive maintenance. What's going to happen down the line? When will the servo overheat or something? That's where we've seen a lot of implementation as well. I think those market sectors are clearly maturing quickly.
So great. Yeah, I want to go back to something you said about trust, because I think trust goes a little bit both ways here. You mentioned how businesses have to trust the solution or the AI to do this correctly and accurately. But I think there's also a trust factor that the person deploying the machine learning models or training the machine learning models know what they're doing. And so when you democratize AI, how can business stakeholders be confident and comfortable that a business or an enterprise user is training and creating these models and getting the results that they're looking for?
Yeah, I think a lot of that starts with the data, really understanding your data, make sure there aren't biases. Explainable AI has become an interesting subject over the last few years as well, looking at, visualizations, different techniques like Shapley values or counterfactuals to see how is this model making decisions? We did a big study on this a few years back. Actually, one of the most powerful ways of getting business decision makers on board and understanding exactly how the model operates, which is usually pretty complex, even for machine learning engineers. Once a model is trained, it's like what kind of magic is going on internally is not always really clear. But one of the most powerful tools is providing counterfactual explanations. So changing the data in subtle ways that you get a different decision. Maybe the machine learning forecast will change, dramatically when, one feature in the database or a few data points or just change very slightly, and understanding where that threshold is. It's like, here's what's really triggering the decision making or the forecasting on the model, and which columns or which features are really important. If you can visualize those, it gives people a much better sense of what's going on and how the decisions are weighted. I think that's very important.
Absolutely. So I'm also curious, we mentioned some of the challenges, a big one being not enough skill sets or data scientists available within an organization. But I think even if you do have the skills available, it's still complex to train machine learning models or to deploy these to applications. So can you talk about some of the challenges businesses face beyond skill set?
Interestingly, so skill set is one, but I think that will diminish over time. There are more and more frameworks that allow people to get access, just data analysts or data scientists to get access to more sophisticated machine learning features. And auto ML has become a thing over the past few years. And you can do a lot. You can go a long way with auto ML frameworks like Data Robot or H2O. What is often challenging are some of the simple things, some of the simple operational things in the short term. On the implementation side, a lot of the rocket science is already done by these, fairly sophisticated core machine learning models, but a huge amount of a data scientist or ML engineer's time is spent on data acquisition, data transformation, cleaning the data, encoding it, building all the pipeline for preparing this data to train and retrain a model, and then maintaining that over time. The data scientist tool set is often based on Python, which is where a lot of these pipelines are written. Python's not necessarily, arguably, not very well adapted to data transformations. And then what happens, you've often got this bespoke Python code written by a data scientist, and maybe things that are being done in a Jupyter notebook somewhere. Then it becomes a pain to update and maintain. What happens when your database tables change? Then what do? You got to go back into this Python, and it's all reliant on this one engineer to kind of update everything over time. And so that's, I think the ML ops side is one of the biggest challenges. How do you do something that is efficient and repeatable and also predictable in terms of cost and overhead over time? And that's something that we're trying to solve. And one of the theories behind our approach, is just to bring machine learning closer to the data and to use existing tools like SQL to do a lot of this stuff. They're very, SQL's pretty well adapted to data transformation and manipulating data. That's what it's designed for. And so why not find a way where you can apply machine learning directly, via connection to your database, and use your existing tools and not have to build any new infrastructure. So I think that's a big pain point, one of the bigger bottlenecks that we're trying to solve actively.
So you touched on this a little bit, but I'm wondering if you can expand on the benefits that the data scientists will actually see if we democratize machine learning. How can they start working with some of those business users, together on initiatives for machine learning?
Yeah. So one of our goals is to give data scientists a broader tool set, and to save them a lot of time on the operational, kind of the cleanup and the operational tasks that they have to perform on the data, and allow them really to focus on core machine learning. So the philosophy of our approach, we take a data-centric approach to machine learning. You've got data sitting in the database. So why not bring the machine learning models to the database, allow you to do your data prep to train a model, let's say, for example, in a SQL-based database, using simple SQL with some modifications of SQL syntax. From the MindsDB standpoint, we're not consuming database resources. You just connect MindsDB to your database. We read from the database, and then we can pipe machine learning predictions, let's say business forecasts, for example, back to the database as tables that can then just be read like your other tables. The benefit there for data analysts and any kind of developer who's maybe building some kind of application on the front end that wants to make decisions, algorithmic trading, or anomaly detection, you want to send up an alert when something's going wrong, or you just want to visualize it in a BI tool like Tableau, is that you can use the existing code that you've got. You simply query the database just like you have from another application. There's no need to build a special Python application or connect to another service. It's simply there, and you access it just like you would access your data normally. So that's one of the business benefits, is that it cuts down considerably on the bespoke development. Is very easy to maintain in the long term, and you can use the tools you already have.
So you mentioned you're working to bring, machine learning closer to the data, or bringing machine learning into the database. I'm wondering, is this how traditionally machine learning models have been deployed, or is there another way of doing it? So can you talk about, how that compares to traditional methods, bringing it into the database versus the other ways that organizations have been doing this?
So traditionally, machine learning has kind of been approached like people would approach a PhD project or something. It's you would write a model using an existing framework like TensorFlow or PyTorch, usually writing a model in Python. You would host it somewhere, probably not with a web server. There are Ray and other frameworks that are well adapted to model serving. And then you have data you want to apply. It might be sitting all over the place. Maybe it's in a data lake, some in Snowflake, some in MongoDB, wherever. You write pipelines to extract that data, transform it. You often have to do some kind of cleaning and then data transformations and encoding. Sometimes you need to turn this data into a numerical representation, to a tensor, and then feed it into a model, train the model. The model will spit out some predictions, and then you have to pipe those back in to another database, perhaps, or feed them to an application that's making some decisions. So that would be the traditional way. So you can see there's a bespoke model that's been built. There's a lot of bespoke, infrastructure, pipelines, ETLing that's been done. That's the way it's been done in the past. With MindsDB, what we did is we had MindsDB has two components. One is a core suite of machine learning models. There's a kind of an AutoML framework that does a lot of the data prep and encoding yourself. And we've built some models of our own, also built by the community. But I forgot to mention, MindsDB is one of the largest machine learning open source projects. We have close to 10,000 GitHub stars. And there's a suite of machine learning models that are adapted, regression models, gradient boosters, neural networks, all kinds of things that are adapted to different problem sets. MindsDB can make a decision looking at your data, what kind of model is best applies, and choose that. The other piece of this ML core of MindsDB is that you can bring your own model to it. So if there's something you like, particularly Hugging Face, which is like an NLP model, language processing model, you can actually add that to the MindsDB ML core using a declarative framework. So back in the day, you would have to, if you want to make updates to a model or add a new model, you'd have to kind of root around in someone else's Python code. But we allow you to do this, to select the model you want, bring your own model. You can tune some of the hyperparameters and things like learning rate or change weights and biases using JSON, using human readable format. So it makes it much easier for everybody to use. And then the other piece of MindsDB is kind of the database connector and this wrapper that sits around these ML models and provides a connection to whatever data source you have. It can be a streaming broker, Redis, Kafka. It can be a data lake like Snowflake. It can be a SQL-based database where MindsDB will connect to that database, and then using the query language, native query language, you can tell MindsDB, read this data and train a predictor on this view or these tables or this selection of data. MindsDB will do that, and then it will make the predictions available within your database. You can query those predictions just like you would a table. So it's a very, very different concept than your traditional kind of homegrown Python-based machine learning applications.
And it sounds like a lot of the features that MindsDB is offering with its solution, data scientists can go in themselves and, expand on their machine learning models and utilize this even more. So if you do have a data science team available within your organization, what would be the benefit of bringing MindsDB in?
This is the thing that I think it's important to make really clear. We're not replacing anybody, and it's not really an AutoML framework. It allows for far more sophisticated, application of machine learning than just a tool that kind of gives you a good approximation of, what a hand-tuned model would do. So it basically, for a machine learning engineer or a data scientist internally, MindsDB would just save a tremendous amount of, that 80% of their work that goes into data wrangling, cleaning, transforming, encoding. They don't have to worry about that. They can really focus on the core models, selecting the data they want to train from, and then, building the best models if that suits them, or choosing from a suite of models that work pretty well within MindsDB, and then also tuning those models. A lot of the work goes into kind of adapting, tuning the hyperparameters of a model to make sure you get the best results. Make that much simpler. You can do that in a declarative way rather than rooting around in someone's Python code. So the whole thing is about time savings, I think, for data scientists. And then in the longer term, if you connect this directly to your database, what it means is you don't have to maintain a lot of the ML infrastructure that up until now has been largely homegrown. If your database tables change, you just change a little bit of SQL. What you're selecting and what you're using to train a predictor. You can set up your own retraining schema. There are just lots and lots of operational kind of time and cost saving measures that come with it. So it allows data scientists and machine learning engineers really to focus on their core job and produce results in a much faster way, I think.
Great. Yeah, I love that point you made, that it's not meant to replace anybody or data science per se, but it's really meant to, boost your machine learning efforts and make things go a little bit smoother.
Yeah, in a nutshell, it just saves a data scientist tons of time and gives them a richer tool set. That was kind of our goal.
So do you have any customer examples or use cases that you can talk about?
Yeah, tons. I mean, they fall into two buckets. We really focus on business forecasting, often on time series data. And time series data can be a bit tricky even for seasoned machine learning engineers because you've got a high degree of cardinality. You'll have like tons of data, let's say, that where there are many unique values in a column. For instance, by definition, that's what a time series is. And if you could imagine, you've got something like a retail chain that has maybe thousands of SKUs, thousands of product IDs across hundreds of retail shops, right? That's just a kind of complex data structure, and trying to predict, what's going to sell well. Maybe a certain SKU sells well in Wichita, but it doesn't sell well in Detroit, and how do you predict that? That's kind of a sticky problem to solve because of the high degree of cardinality in these large multivariate time series. But it also tends to be a very common type of data set for business forecasting. So we've really focused our cutting edge large models on time series forecasting. So that's what we do. We will tell you what your business is going to look like in the future, in weeks or months. The other thing that we see in the use cases, so it's forecasting on time series and then also anomaly detection. So, it's fraudulent transactions, or, is this machine about to overheat? Getting down into the details, I can tell you, you know, across the board, there are all kinds of different use cases we implement. One very typical one is it's for a big cloud service provider. We do customer conversion prediction. They have a generous free trial tier, and we can tell them with a very high degree of accuracy based on lots of columns in their customer data store and lots of different types of customer activity and the structure of their customer accounts, who's likely to convert to paying tier and when, and precisely when, which is kind of important for their business planning. We're working with a large infrastructure company, telco, on network planning, capacity planning, so we can predict fairly well, where network traffic is going to go, and where it's going to be heavy and not, and where they need to add infrastructure. We've also worked on this is a typical kind of IoT case, manufacturing process optimization in semiconductor. So we can look at in real time sensor data coming in from the semiconductor process, and we can say when do you stop and go on to the next phase of the process, and where defaults also likely to arise based on some anomaly detection on the process. That's one. That's one we've seen. We've been working on one project in particular, but we've seen a couple like that in pilot phases. We're doing credit scoring, real estate, like payment default prediction as well as part of the business forecasting. So those are all typical, and we across the board we see forecasting problems on time series. One of the actually most enjoyable projects is kind of unique and interesting, but is really close to my heart. Is we're working with a big esports franchise building forecasting tools for coaching for professional video game teams. Like, what can you predict what the other team's going to do for like internal scrimmages and internal training for their teams, and what would be the best strategy given a certain situation on some complex like MOBA games like League of Legends or Dota 2. So that's something we're working on right now. They've already built the tools in the front end of these forecasting tools, and we're working with very large data sets, proprietary data sets of like internal training data to help them optimize their coaching practices. It's kind of an exotic case, but I guarantee you that's going to grow in the future. So that's one of the most interesting ones.
So lots of different use cases and ways that you can bring these capabilities into your organization efforts. But I'm wondering, in your experience, what is the best place to start on a democratizing machine learning for a business? Where can businesses start using this, and what do you recommend they start?
Super easy. Cloud.mindsdb.com. We have a free trial tier. It's super easy to set up and get you sign up for an account. And then we have, God knows how many, 50 plus data connectors. Wherever your data is living, you can simply plug in MindsDB and start to run some forecasting and do some testing and see how it works. I mean, you can take it for a test drive immediately. That's kind of one of the first things that I would recommend that you do. The other thing is you can join our community. If you go to mindsdb.com, we've got a link to our community Slack and to GitHub, which is extremely active. And there you can find, support and tips. And, if you're trying to solve a problem, almost guaranteed someone solved it before and are available on the Slack community.
Great. I love when projects and initiatives have a community behind it, because it's really important to learn what other people have been doing and to get that outside support or outside thinking that you may not have been thinking about. And I know you mentioned, Eric, in the beginning, you guys are also working with Intel on this. I should mention the IoT chat and Insight.tech as a whole are sponsored by Intel. But I'm curious how you are working with Intel and what the value of that partnership has been.
Yeah, so that's actually been Intel has been extremely supportive on a number of fronts. So obviously, Intel has a great hardware platform, and we have implemented their OpenVINO framework, which is optimizes machine learning for performance on Intel hardware. So made great performance gains that way. And on top of that, Intel provides tons of technology and kind of go-to-market opportunities. We work with them on things like this. I'll be presenting at the end of the month. If anybody wants to come check us out at Intel Innovation in San Jose, I think it's on the 27th, 28th, 28th, 29th of this month at the San Jose Convention Center, and we'll have a little booth in the AI ML part of their innovation pavilion, and I'll be demoing how we work, running some machine learning on data in MariaDB, which is an Intel partner. Actually, MariaDB introduced us to Intel, and that's been really fruitful. Their cloud services are hosted on Intel. So if anybody wants to come and check it out, that's Intel has provided us this forum. So we're extremely grateful.
Perfect. And Insight.tech will also be on the floor at Intel Innovation. So looking forward to that demo that you guys have going on there at the end of the month. Unfortunately, we're running towards the end of our time. I know this is a big, important topic, and we could probably go on for a long time, Eric. But before we go, are there any final key thoughts or takeaways you want to leave our listeners with today?
I would just urge you to go. I mean, we love the feedback. Even if go test it out. It's actually fun. MindsDB is pretty fun to play with. That's kind of how I got involved. I discovered MindsDB by chance and installed it and started using it and found it was just useful in all kinds of data sets and just doing science experiments. We love it if you take it for a test drive and provide feedback on the community Slack. We're always looking for product improvements and people to join the community. And so we'd really welcome that. Cloud.mindsdb.com. And thanks very much for the opportunity, Christina.
Yeah, of course. Thank you so much for joining the podcast today. It's been a pleasure talking to you. And thanks to our listeners for tuning in. If you like this episode, please like, subscribe, rate, review, all of the above on your favorite streaming platform. And until next time, this has been the IoT Chat.